All right, so we are going to continue with our next lesson on arithmetic sequences today. Last class, we talked about arithmetic sequences and just started recognizing patterns that add by the same number every single time. And we started kind of writing rules for those, but today we're going to talk about a specific formula and two different formulas actually that we're going to use to describe arithmetic sequences. So before we talk about the formulas, we do have some new variables that we need to define. So these are the variables that you're going to use in all of your rules. And we'll start with the first one, which is a sub 1. And when I'm saying that, I'm saying a sub 1. Okay, because the 1 is down below, it's called being down in the subscript. So when you type these in, you will use the sub button to get this down in the subscript. It's not right next to the 1, it's down a little bit lower. So a sub 1 is how we read that, and that's going to represent our first term in the sequence. Then we have this variable d, we talked about a little bit last class, that represents the common difference. And that common difference is the number that's added each time to get the next term in our sequence. Okay, and then we have this variable n, and n is just representing the term or the position number, so where it's at in the sequence. If n is 5, we're talking about the 5th term. If n is 10, we're talking about the 10th term. And then we have if n is 1, that is our first term. So that's why we wrote this like a sub 1. And then we have a sub n, which could be any term. So if we have a specific number there, that's the term we're talking about. But if we just have n there, we are talking about the nth term. So any term. And then if we have a sub n minus 1, that is talking about the term before n. So I'm going to use the phrase the previous term. And you'll see when we come up with our rules, when I see that notation a sub n minus 1, I'm going to describe that as the previous term. So these 5 things are all going into our rules or our equations for arithmetic sequences. These are all variables. So kind of like when we had linear equations and we had y equals mx plus b, we were working with 4 different variables, but we got comfortable with those equations, knew what those variables represented. So we need to do the same thing with these variables that we're using for our sequences. So before we talk about the rules, we're actually going to see if we can figure out where they come from. So this is a sequence 7, 9, 11, and it keeps going. And then we can see in our table the first term is 7, and the second term is 9, and they got that from doing 7 plus 2. And then the third term is 11. They got that from doing 9 plus 2. So if we follow this pattern and just wanted to continue this table, we could figure out what comes next. So following this pattern, they did 7, and then 7 plus 2 is 9, and then 9 plus 2 is 11. So next we would do 11 plus 2, which is 13, and then 13 plus 2, which is 15. And I think you could figure out the next two in that pattern. And then we get down to this bottom box and it asks us to figure out the nth term. So this means we're trying to generalize for any term in the sequence. What were we doing each time? So to get the fifth term, we did 13 plus 2. And where did that 13 come from? It came from this term before it. To find the fourth term, we took the third term value and added 2. To get the third term, we took the second term value and added 2. So each time we were getting this first number from the previous term. So we had a variable at the beginning that represents the previous term. That was our a sub n minus 1. So to find the nth term, we would need to take the previous term, a sub n minus 1, and add 2. And that would get us the value of a sub n. So we just came up with the recursive rule. Recursive means that we use the previous term to find the next term in the sequence. So in order to know that we can always find the previous term, but we also need to give the starting point. Otherwise, we don't know where to start. So we need to start with a sub 1 equals whatever the first term is. So in this case, our first term is 7. So you would write a sub 1 equals 7 to start this rule, just so we give a starting point. Then the second part, we would write a sub n equals, and just what we set up here, to find any term, we take the previous one, and in this case, we were adding 2 every time. That 2 came from, in the original sequence, we could figure out that each time we were adding 2. And remember, we have a variable for that number. It is our common difference. The number that's added each time is the common difference. So we know D in this example equals 2. So in any rule, any sequence, we would just add whatever that common difference is. Okay, so the recursive formula for arithmetic sequences, we write a sub 1 equals the first term, and a sub n equals a sub n minus 1 plus d. Then we're going to switch gears, and there's a second type of rule that we need to know for sequences. So we're looking at this same pattern, 7 to 9 to 11, so we know we're adding 2 every time, but this is kind of showing us a little bit different way to find the next term and figure out what that next value would be. So we start at 7. To get the next term, we do 7 plus 2. To do the next term, we do 7 plus 2 plus 2. So figuring out that pattern, the fourth term, we would do 7 plus 2 plus 2 plus 2. And then here, they simplified it. So if we're adding repetitively, we know we can change that to multiplication. So the first one they did 7, and then 7 plus 2 times 1, and then 7 plus 2 times 2. So this would be 7 plus 2, and we had 3 of them there, so times 3. And then they generalized it using the variables that we know. So we know a sub 1 represents our first term, and that first term was 7. So each time we were starting with 7, we're really starting with a sub 1, the first term, and then each time we were adding 2, and that's our common difference. So we're adding D plus D plus D. Okay, same thing here. We have 3 of those d's, so we can change that to multiplication and write a sub 1 plus d times 3. And to figure out that value, we know 7 plus 2 times 3 would get us 13. And you could continue that pattern if you need to see what's happening, but I think at this point it's kind of easy for us to see what's going to continue. So to find any term, the nth term, we would do a sub 1 starting with our first term, and then we're just adding that common difference over and over and over again. So if we want to talk about how many times we are adding d, we need to look for the pattern here. So for the 4th term, we added it 3 times. For the 3rd term, we added it 2 times. For the 2nd term, we added it once. So if we're following that pattern and we think about it, if we were going for the 7th term, we should be able to recognize this would be a sub 1 plus d, and 1 less than 7 would be 6. So it's always 1 less than the term number. So if our term number is n, that means we would want to do a sub 1 plus d, and we would want to have 1 less than n, which we can write as n minus 1. And that's going to find us our term value, a sub n. Okay, so that is our explicit formula for arithmetic sequences. If we have a sub n, we want to find any term. We would take the first term, a sub 1, and add the common difference d, n minus 1 times. So a sub n equals a sub 1 plus d times n minus 1. Then it asks us what's the difference between the first table and the second table. So we have these 2 different types of rules. They're slightly different, and they're different in the way that we would use them also. So if we look at this one, okay, we just need to know the first term and the common difference, and if we know those 2 things, we can find the term value. This one requires us to know the previous term. So we have to know the first term, we have to know the common difference, and we have to know the previous term. So the difference between the 2 is that the recursive formula can be used to find a term value when you know the previous term value. And the explicit formula can be used to find any term value. So if I wanted to find the 6th term and I already had the first 5, we could easily use the recursive formula to find that. But if I wanted to find the 100th term and we were only given the first 5, you would probably want to use the explicit formula because you can go straight there. If you use the recursive formula, you would have to list out every single term till you got to the 100th term. Okay, so now that we've looked at those rules a little bit, our goal is to use arithmetic sequences and their formulas to find any term in the sequence, and to just write those recursive and explicit rules that represent any arithmetic sequence. So sequence is a term we've already talked about. It's just our numbers in a list that follow some sort of pattern. We are focused on arithmetic sequences right now, which means we are adding the same number, which we call our common difference, every single time. So here are the rules again, just written out for you. The explicit rule, this is one we can use to find any term in the sequence. And we start with a sub n, which is our nth term. A sub 1 is our first term plus the common difference, d, times n minus 1, and n again is our term number. When you actually write the rule, you need two things. You need the first term, a sub 1, and the common difference, d. And those are the only two things that you're going to plug in. So kind of similar to when we had y equals mx plus b. And when you wrote your y equals mx plus b equations, you left y and you left x, and you just had to plug in the value for m, and you had to plug in the value for b. So that's what we have to do here. Everything here we just copy down, but we plug in our value for a sub 1, we plug in our first term, and we plug in the value for the common difference. What is the number that we're adding each time? And it's the same on the recursive rule. So the recursive rule, we write a sub 1 equals the first term. So you need to plug in what that first term is, and then a sub n equals a sub n minus 1 plus d. And on this one, you copy everything, but you need to plug in what the common difference is. So it's the same on each one. You plug in the first term, and you plug in the common difference. You plug in what the first term is, and you plug in the common difference. And everything else in the rule, you just keep the same. You're just writing the equation with those things that are boxed plugged in. Okay, so there's an example here of how we can use the rule, but we have more examples on the back, so I'm going to skip ahead to those. Starting with identifying arithmetic sequences. So first, just determining if they are arithmetic, meaning are we adding the same number every single time? So if we look at this one, we go from -4 to -2 to 0 to 2. We can see every time we are adding 2. So if we're going to continue that pattern, we just keep adding 2. So 2 plus 2 would be 4, and then 6, and then 8. And then part B, we have 1/2, 3/4, 1, and 5/4. So this one, it's helpful to get these to a common denominator so we can see it a little bit better. So instead of 1/2, I'm going to write 2/4, and then 3/4, and then I'm going to rewrite 1 as 4/4, and then 5/4. And now it's easy for us to see we are going up by the same amount each time, and that number is 1/4. So if we go up 1/4 from 5/4, we would have 6/4, 7/4, and then 8/4. And we can simplify those to 3/2, 7/4, and 2. Part C, we have the same thing, fractions, so we want to get a common denominator, which is going to be our biggest one, 16. So we would have 8/16 and 10/16 and 12/16 and then 13/16. And if we look, it's going up 2/16, and then it's going up 2/16, but then it's going up 1/16. So no, we don't have a common difference. It's not the same every time. So this is not arithmetic. Then we're going to practice writing the rules. So the second set of examples, we want to write the recursive and the explicit rules. So we'll start with recursive, and for that we can refer back to this if we need to. We are writing a sub 1 equals the first term, and then a sub n equals a sub n minus 1 plus d. So a sub 1, the first term is 15, and then a sub n equals a sub n minus 1. We need to plug in the common difference. So we go from 15 to 9 to 3 to -3. So we can figure out each time we are subtracting 6. So d equals -6. So we would plug in -6 for our common difference. And this whole thing is our recursive rule. We need both of those parts together. Then the explicit rule, again, I don't expect you to have this rule memorized, so go back to it, look at it. We have a sub n equals our first term, which is 15, plus the common difference. In this case, it was -6 times n minus 1. And that's it. There's our recursive rule. There's our explicit rule. Then the next one, we have 1/4, 3/4, 5/4, and 7/4. So each time we are adding 2/4, which is the same as 1/2. So we can write the recursive rule first. We start with a sub 1, and our first term is 1/4. And then we write the second part, a sub n equals a sub n minus 1 plus the common difference, which was 1/2. And then our explicit rule, we just write a sub n equals, plug in our first term, which is 1/4, plus plug in our common difference, 1/2, times n minus 1. Okay, so we came up with the recursive and explicit rules for that one too. Then we need to be able to actually use those rules. So these examples, this one we have a sub 1 equals 19, a sub n equals a sub n minus 1 minus 5. So this is an example of a recursive rule. It tells us the first term is 19, and it tells us our common difference each time we are subtracting 5. So we just need to follow that pattern to find the next terms. 19 minus 5 is 14. Minus 5 is 9. Minus 5 is 4. And minus 5 is -1. And we're done. This one, there's two things we could do. So we could look at it, and we know this is an explicit rule for an arithmetic sequence, which means this is our first term, and this is our common difference. So our first term is 15, and each time we are adding 2.5. So we can just do that math and add 2.5 to get 17.5, plus 2.5 is 20, plus 2.5 is 22.5, and plus 2.5 again is 25. The other thing we could do is make a table with n and a sub n, and we're plugging in the values 1, 2, 3, 4, and 5. And if we plug in those values here, we'll get what those terms are. So we would just plug in 1 for n, see what we get, plug in 2, see what we get. But we already have those numbers, so I'm going to save that process for these next examples. This one we have the sequence 0, 4, 8, 12, and we want to find the 8th term. And we have the first 4 terms. The 8th one is not too far away, so we can just continue the pattern. We're adding 4 every time. So if we keep adding 4, we would get 16, 20, 24, and 28. And now we have 8 terms in that sequence. The 8th one is 28. Part B, we probably don't want to list all those terms until we get to the 75th term. So instead, this is where those rules come in handy. So we're going to use the explicit rule, because that's going to help us find any term. And we'll write that for this sequence. So a sub n, again, equals our first term plus the common difference times n minus 1. So our first term is 9. The common difference on this one, we are subtracting 6 each time. So D equals -6. So we would write -6 times n minus 1. So there's our explicit rule. Now we're going to use it to find the 75th term. So we are looking for a sub 75, the 75th term. To find that, we use this rule and plug in 75 for n. So now we have 9 minus 6. We can do 75 minus 1 to get 74. And then order of operations, we want to do -6 times 74 first, which gives us 444. So we have 9 minus 444. And then if we do that, 9 minus 444 is -435. So there's our answer for the 75th term in this sequence. And last one, this one's a little more challenging because we have some missing information. So we would need to figure out that information before we can continue. So we know the first term is -6. And we know the 21st term is 634. So this tells us what we need to find first. We would need to find the common difference. And we don't have consecutive terms anymore, so we can't just see what we're adding each time. But we know from the first term to the 21st term, we're going up 20 terms. And from -6 to 634, we are going up in value by 640. So if we go up 640 over 20 terms, 640 over 20 is going to tell us how much we go up each term. So 640 divided by 20 is 32, and that is our common difference D. Then it asks us to write the explicit rule. So again, the explicit rule is a sub n equals a sub 1 plus D times n minus 1. We need to plug in what our first term is, and we know that from the problem. It is -6. Then we need to plug in our common difference. We figured out that that's 32. And there's our explicit rule right there. And then it asks us to find a sub 11, which is the 11th term. So on this one, just like our previous example, we're plugging in 11 for n. So -6 plus 32 times 11 minus 1, which gives us -6 plus 32 times 10, which is -6 plus 320. And finally, we just get our answer of 314. So a sub 11, the 11th term, is 314. Okay, so those are all the examples that we're going to go through. Use those to help you with your assignment.